Terrain Pilot Quick Modeling Tutorial. Mounting the sensor. After mounting the sensor to its bracket, secure the bracket to the spreader beam using steel zip ties. To prevent slipping, it's recommended to apply double-sided adhesive tape between the bracket and the beam. Mounting the GNSS receiver. Attach the magnet to the bracket and tighten it with screws. Then, mount the GNSS receiver onto the bracket and secure it firmly with the large screw. Note, be sure to use anti-slip washers under the screw head to prevent loosening. Align the receiver as indicated on the bracket during installation. Secure the bracket to the boom with magnets. To prevent vibration from shifting it, apply strong adhesive to the magnet backs. In wooded areas, simply loosen the screws to remove and store the bracket. Reattach it when needed. Installation notes. With the quick modeling function, there is no longer a requirement for the sensor to be parallel to the BC axis, nor does the bracket need to be aligned with the AB axis direction. You can mount the sensor and bracket in any orientation or position. However, once modeling is complete, do not move the sensor or magnet position again. Otherwise, remodeling will be required. Connecting the sensor and GNSS receiver. First time setup, tap the GNSS receiver and sensor icons to enter the search pairing screen. Tap Search, select your devices, then tap Connect. Once both the receiver and sensor show a successful connection, return to the home screen. If the data link icon does not show a check mark, first check your mobile network signal. If the network is normal, tap the data link icon to enter its settings. Select Autofix, tap Apply, and return to the home screen. The check mark should appear shortly. You're ready to work when all three icons, GNSS receiver, sensor, and data link, display a check mark. For subsequent use, simply tap the Connect button. The software will automatically link the receiver, sensor, and data link. Once all show a check mark, you can start working. Measuring the parameters. Once the GNSS receiver and sensor are connected, tap Quick Modeling, select the position where the bracket is installed, and proceed to the next step. If using an L2 bracket, there is a threaded hole at its bottom, the Z-point, where you can attach an auxiliary rod to hang a plumb bob. If using an L1 bracket, the Z-point is located 1 cm upward from the center of the bracket's bottom surface. After hanging the plumb bob, adjust the boom and bucket position so the plumb line passes through points A and D. Note, if a quick coupler is present, points A and D are on its upper section. Treat the coupler as part of the bucket, do not measure from the lower section. If the bucket ear is prominent, keep the plumb bob clear so it hangs freely. Once Z, A, and D are vertically aligned, stop the engine, measure all lengths and enter them. Measure the bucket tip parallel to the boom. Using the second tooth tip reduces error. Point G is on the bucket's backplane. DG is perpendicular to it. Attach a rod to point D to estimate DG. Measure to the nearest millimeter, enter in meters. Next, enter the excavator and bucket IDs. Any identifier works, like the model number or 1234, just to distinguish between machines and buckets. Then enter bucket width MN and track width L. Note, PQ is the distance from the GNSS receiver's center line to the boom center. Measure it in sections. First from the receiver to the boom side, plus half the boom width, then subtract the boom edge thickness. After entering all parameters, tap Finish. Accuracy check. 2 ways to check accuracy. First, use Params check. Pick a level surface, water, or ground, follow the steps, and view the error after collection. Second, use the leveling function. Start a new job, place the bucket tip on the level surface, and set the height with the center or left tip. Then move the boom and bucket to different positions and watch the cut fill values. If error stays under 3 centimeters, it's good. If over 5 centimeters, remodel.